So in this video, I'm going to explain how to report some basic descriptive statistics and bivariate correlations when you have a combination of categorical and continuous variables. So the descriptive parts can be relevant to any study design, but the bivariate correlation is relevant if you have a correlational study. So because the bivariate correlations are always presented as a general picture of the bivariate relationships between the variables, even though you are using other complex methods for testing your hypothesis. Like, for example, if you are using multivariate regression or other types of analysis, it's always recommended and expected that you report a table of bivariate correlations as well. And also, the results of your descriptive statistics also can sometimes inform which type of bivariate correlation you may want to choose for that part of your analysis. So let's start with descriptive statistics in JASP. So in JASP, we can choose descriptive statistics, and actually JASP can be much simpler than SPSS in some aspects for both of these type of analysis. So just before that, sorry, I forgot to explain that the variables that we have here. So we have like three demographic variables, that is, age is a continuous variable, gender as a categorical variable, marital status also as a categorical variable. And I have also five key variables. That is one of them, like is IV1 to IV4 is my independent variables. And I have three version of my dependent variable. Like depression is my dependent variable that is presented in three different versions. One version is a continuous version that like the just scores of the raw score of participants in the measure of depression. And I have two versions of categorical variable. Like for example, I have one version that is ordinal categorical that like shows that it categorizes participants in based on mild, normal, severe, extremely severe categories of depression. And also I have another version of categorical depression that I have categorized participants in just in two categories, like non-clinical or clinical levels of depression. So I may need to use a different version of this variable in different types of analysis that I'm going to run. So I explain that shortly. So now we're going to descriptive statistics. So, and you know that you use descriptive statistics not just for your results section, you also need descriptive statistics for your method section as well, especially for reporting the participants' characteristics, like the demographic characteristics. So I have like, first, imagine that I just want to see descriptive statistics for my demographics. So I have age that's putting here. And in JASP, it's okay. You can put all of the continuous and categorical variables together here. But in SPSS, you might choose different options. So, but here in JASP, so I have age as a demographic variable, marital status here. I have also uh, gender that I want to include here. So as you can see, it just gives me the relevant information now for age, like gives me the mean for age, standard deviation for age, and maximum and minimum. But as you know, these statistics are not applicable to categorical variable. That means that although they are applicable to age, but they don't give me useful information for gender and marital status because they are categorical. So if I want to see the relevant descriptive statistics for my categorical variables, I need to go down to tables like here and tick for frequency table. So when I do that, you can see that now I have the information that I need for my categorical variable. I can now see that the frequency for each level of my gender as a categorical variable, that is, for example, I know this number for female, this number for male, non-binary, no missing data. And I can also see the percentages of uh, this that valid percentage also is similar. The percentages of these frequencies, like for example, I see that the majority of my participants, 53, almost 54% are female, and the rest are male and non-binary. And like for example, for marital status also, I can see that here, that I can see like for example, the majority of my participants are either married or single, that around like 63%, and like lower number is de facto. And also 2%, or less than 1% also like mentioned that the other options, they chose other options. So, and you see that, so I check my categorical variables in these tables, frequency tables. After I tick that here, it's not by default activated. Either I tick that here, you can see that it appears through these tables, and I can check the descriptive statistics for my continuous variable, that would be mean, standard deviation, minimum, maximum for this table. So these are the relevant statistics for continuous variables, and frequency and percentages are relevant statistics for categorical variables. So these are my demographics. Now I have every information I need to report in my method section. But how about my results section? So for my result section, I can also add other variables that I have, like my IVs that I can put here. And also for my DV, although I have now, this is the point that I need to decide. So I want to report like mean and standard deviations and also minimum maximum for my variable. So which version of my DV is better for this purpose? So I would say that depression, I mean, both actually can be, like, let's try all of that. All of that can be helpful depending on the purpose of my results section, what I'm going to report in my results section. For example, I can include let's see that now, the variables that we have here. For example, these are for my independent variables that I can select for example, my independent variable 1, the mean, standard deviation, minimum, maximum, I can check here, the same for other one. And now for the continuous version of my dependent variable, I can check this table still. That is depression total is the continuous version of my dependent variable. That means that like the mean of my sample is 10 on this score. With the standard deviation also is very wide, that you can see almost it's also 10, and minimum is 0, like I have participant reporting no depression, and I have participant reporting the maximum level of depression, that is like 42. That's why you see that we have a huge standard deviation here. So this is all I need from this table. I don't need to check the categorical version of my dependent variable in this table because it's not relevant to this table. For the categorical version of my dependent variable, I can go to frequency tables, that is here. For example, here, this is the ordinal categorical version of my depression variable. So it can give me some useful information. For example, I know that 48% of my sample reported mild depression. 68 actually, not 48%, sorry, 48 people mentioned that mild depression, 68 people mentioned moderate depression, and here also is the percentages. For example, maybe the majority, like almost half of the sample, 50% of the sample reported normal levels of depression. So in this case also it can be helpful depending on what I want to report in my results section. And also I can maybe, instead of this, I can report this table that just has two categories, clinical versus non-clinical, and I can see that like 63% of my sample, that the majority of my sample has reported non-clinical levels of depression. And so that's all that we could see for descriptive statistics that we needed in terms of like the key variables. However, it's not all we can check in this section. Still, there are two more important steps that we can check in descriptive statistics. Like one step is testing for normality. That if you are using a type of analysis, inferential statistic that needs normality of distribution of your data as an assumption, you can tick here Shapiro-Wilk to test the normality assumption for your inferential statistics. So the Shapiro-Wilk, as you can see, will appear in your first table. That is that you just need to check this row, the statistic for Shapiro-Wilk, and also more importantly, the p-value for Shapiro-Wilk. So as you might know, Shapiro-Wilk can show that the distribution of your data for a certain variable is normal if the Shapiro-Wilk is not significant. And we just need to check it for key variables, like for example, for these IVs and the continuous version of our DV. And you can see that it's significant for all of them because it's less than 0.05. That means that the assumption of normality has been violated for all of our key variables, for 4 IVs and 1 DV, the continuous version of our DV that we have here. So that means that if you have a type of inferential statistic that needs normality as an assumption, then you need to do some extra steps to make sure that this assumption violation is not affecting the results of your inferential statistic. So the last thing that is useful to check in your descriptive part of your analysis is checking for outliers. And that is so through box plots that I'm just trying to now, yes, here, that is customized plots. If you tick for box plots and then ticks for label outliers. In this case, and also I'm going also to remove the irrelevant variables because I need to just check the outliers for my key variables. Like for example, for my IVs and the continuous version of my DV. Sorry, I missed one IV. So now I have just the continuous versions of my IV and DV. For that purpose, I just need to check the outliers. And you can see that this table, this plus actually can show specific outliers for each variable. For example, for my first IV, participant number 71 in my data set is an outlier. Is a potential outlier. I cannot say that they are influential outlier or not. Like you can see for the second IV, there are a lot more outliers, like participant 77, participant 253, etc. There are outliers. I can see that like my this IV, like depression, I don't have any outliers. The data recognize no outliers. Also for IV3, no outliers is recognized necessarily. So what does it mean? Does it mean that I need to remove all of these participants from my data set? Not necessarily, because this information about the outliers are just about a very initial understanding of outliers. It does not mean that they are necessarily influential outliers. That mean that they may not affect the results of your inferential statistics. So if your analysis for inferential statistics include a measure of testing influential outliers, then you don't need to care about these results. For example, if your inferential analysis can test for Cox distance, then the Cox distance can tell you if you have any outlier that can influence your regression models. But if you don't have that one included in your inferential statistics, for example, in ordinal logistic regression, there is no measure to test inferential outliers. Then what you have here can be essential to check if you have an influential outliers or not. How to test it? So, for example, if I want to see these participants are influential outliers or not, I can run my inferential statistic, for example, a regression analysis, a logistic regression analysis. I can run my analysis first without removing or filtering any participant and see what results I get. So then I save those results and I run my analysis another time, but this time before running the analysis, I remove all of these outliers from my data set, or I just filter them in my data set, and I run the same inferential analysis again, like the same regression model, I run it again, but this time without these outliers, with all these outliers excluded from my data set. And if my results are similar to the first time, that similar to the time that I ran the analysis based on the original data set, then I can conclude that these outliers are not influential. That means that they don't affect the main results. For example, if they don't change any significant or insignificant results from the first time that I ran the analysis, so that means that I can keep these outliers because they don't change anything significant in my data. For example, if in my first analysis, the relationship between my IV1 and DV is significant, and then I remove these outliers and this relationship is still significant, so that means that there are not influential outliers. But if the relationship is significant, only if these outliers are included in the data set, so that means that they are influential outliers, and so then I may need to remove them. So, and also I will explain that later in another video that we have about some inferential statistic like logistic regression. So this is all for descriptive statistics. And now let's move to uh, correlation, like bivariate correlations, that in JASP we can do it in as a part of like a regression section of JASP. Although bivariate correlation are not necessarily regression analysis, but in JASP it's categorized on the regression section. So you choose correlation and you choose the variables that you want to run your correlations for example. And again, you can decide, for example, I have now for my DV, I have three types of my DV to be included in bivariate correlation. So which one should I use? I would say, although you can include a categorical version of your DV in your bivariate correlation, I would suggest that if you have a continuous version for your DV, it's better to include the continuous version. So if you, for all types of your variables, if you have a continuous version for your key variables, for the bivariate correlations, I would recommend that you just include the continuous versions of your variables. And then you can just see that how they are correlated to each other pairwise. And so in JASP, by default, the bivariate correlations is run just for Pearson correlation. However, you can also check this for Spearman or Kendall's correlation. So why should I need to check it for Spearman or Kendall? That is because the normality based on some like a statistical references or textbooks, if you want to test hypotheses based on Pearson correlation, you may need to check the assumption of normality for Pearson correlation. And when the assumption of normality is violated, like for example, what we show here, like for example, the Shapiro-Wilk result was significant. That means that the assumption of normality is violated. That means that if you want to have a conservative, a more robust interpretation of the results of Pearson correlation, so you should be mindful that the assumption of normality, which is an assumption for Pearson correlation, is violated. So in that case, you may want to, in addition to that, check also for Spearman-Rho correlation. Spearman-Rho is actually the non-parametric version for Pearson correlation. That means that it gives you the same results, but the good point for Spearman is that it does not assume normality in the data distribution. That means that even if your normality assumption is violated, it's not going to affect the result of a Spearman rule. So also, how about Kendall? Kendall also is similar to a Spearman, but we use Kendall only if your sample size is too small. Like for example, it's less than 100 participants, which is not the case for our sample because we have over 300 participants here. So, do I need to report a Spearman alongside Pearson? It depends. It depends on what is your purpose of reporting Pearson correlation. For example, if my purpose of reporting Pearson correlation is just to present a descriptive picture of my correlations, simple correlations between my variables, but I am not going to use Pearson correlation for any hypothesis testing. For example, I'm not going to use the results of this table to say that my hypothesis one, for example, is rejected or not rejected or confirmed. I'm just going to report this table alongside my descriptive statistic to show just how my variables, all of my variables can be correlated to each other without having any inferential interpretation of that. So in that case, there are many statisticians that says that it's okay if you just report Pearson correlation and don't worry about the assumption of normality. You even may not need to check even the assumption of normality because your purpose is just providing this result as descriptive results. However, if you are going to test hypotheses based on Pearson correlation, or maybe not, but you want to just to be very conservative in presenting your results, then you can test the Spearman correlations alongside Pearson correlations as well. And if you see that the results are consistent, like for example, you see that the results are significant for both Spearman and for Pearson, we can see that it's the case for all of the variables of bivariate correlations, that the results are significant consistently for both Spearman and Pearson. So in that case, I can say that because the results of Pearson and Spearman, that the result of the parametric and non-parametric results are consistent, that shows that the violation of normality has not affected the results of Pearson correlation. So I can just ignore the Spearman, I can just report the result of Pearson correlation. But it's also okay if I just want to report the results of Spearman correlation based on the ground that the assumption of normality was violated. So there are multiple options of reporting the results and all are acceptable. Like either just reporting Pearson even without assumption checks or reporting Pearson and just having a note that you have checked the SBMN result and it was consistent with Pearson, and so it shows that the violation of normality did not affect the result, and so you just present the Pearson correlation, or you just report the SPMN results based on the ground that the assumption of normality was violated. And also the interpretation of the result also is very simple. So you just check the p-value and see that it's a significant correlation or not. And also you pay attention to the direction of the correlation. Like for example, you can see that IV2 and IV1 are negatively correlated. That means that higher levels of IV2 can be associated with lower levels of IV1. However, you can see there is a positive association for IV3 and IV2 because higher levels of IV3 can be associated with higher levels of IV2. However, with just talking about associations or correlation, we don't talk about prediction. Prediction language is just for regression context. In bivariate correlations, we don't have any assumptions that which variable can predict the other one. We can say that they are just mutually correlated. We can say that which one is predictor and which one is outcome. That is the language of regression analysis that I explained in another tutorial video. So that was all for uh, descriptive statistics and bivariate correlations.